oil do we use every day? The U.S. Energy Information Administration estimates that 19.69 million barrels of petroleum products such as gasoline, diesel fuel, heating oil, and jet fuel are used each day in the United States alone. This roughly amounts to an Olympic swimming pool worth of petroleum oil being drained every 15 seconds. But there isn't simply a hotspot of this valuable resource somewhere out there in the world. Instead, it must go through increasingly expensive methods of extracting and refining fossil fuels to produce commercial oil. It is the same oil that we use in our everyday lives, from plastics to pump to medicines. What is biofuel? What problems do gas raise that biofuel can solve? Biofuel is a type of fuel that derives from living matter, such as vegetable oils and liquid animal fats. Conventional oil raises problems such as greenhouse gas emissions that can be solved by converting to biofuel, because the amount of carbon dioxide absorbed by the plants is roughly equal to the amount of carbon dioxide expelled while burning the fuel. Since they are procured from sources that are sustainable for everyday use, algal biofuels are an increasingly viable option for the future of clean energy. However, not all biofuels are equal. Some oils and fats have a higher percent yield for fuel than others. For example, corn-based biodiesel can produce 18 gallons of oil per acre per year, compared to a sunflower's 102 gallons. Yet, the largest yield of all comes from microalgae, at an astounding 5,000 to 15,000 gallons of oil per acre per year. What is algae and algae fuel? When was it discovered, and how long has it been used as an alternative fuel? Where can it be made? Single-celled microalgae can produce large amounts of fat through photosynthesis, thus resulting in a much higher yield than any other renewable feedstock. Still, despite the amount of fuel it produces, it still is quite expensive to manufacture on a large scale. As microalgae have no direct food value to humans, it does not require the same opportunity cost between biofuel and food products. Algae fuel received impetus during the 70s energy crisis, 2 decades after it had originally been proposed to be used in the production of methane gas. The Department of Energy supported the ASP, or the Aquatic Species Program, from 1980 to 1996 in producing oil from microalgae. Algae is a very versatile fuel source that can be grown in cultivation ponds of freshwater, saltwater, and even wastewater. The advantages and disadvantages of algae as an alternative fuel chart. Advantages: renewable, fast-growing, high biofuel yields, consume CO2 and produce oxygen. No agriculture competition, can purify wastewaters. Byproducts can be used in the production of many useful products including plastics, fertilizers, and chemical feedstocks. Disadvantages: need controlled temperature conditions, cold flow, requires fertilizer, including phosphorus and nitrogen. Too expensive to be sustainable, degrade more easily than other biofuels. Fun facts about algae. Although algae is plant-like, it is actually in the kingdom Protista because it is observed to be motile. Algae grows at a rate that allows it to double its size in just 24 hours. That's 27 times faster than your skin. Algae produce more than 71% of the Earth's oxygen. That's higher than the percentage of the Earth covered by the ocean. Algae lower the pH of water by absorbing the carbon dioxide found in it. Look at this litmus paper I used to test the pH of Ellis Lake water. It's Gucci, practically, and the algae likely had a large role in regulating the water's pH. Algae has other practical uses aside from biofuel, like fertilizer and antibiotics. What is the chemical structure of biodiesel? Understanding how algae biofuel works requires an understanding of the basic chemical processes that occur during its production. Regular diesel consists of a long hydrocarbon chain. Biodiesel also contains a long hydrocarbon chains, along with an ester functional group. This allows it to burn just like diesel would. Vegetable oil used in biodiesel production also contains long hydrocarbon chains like the ones seen in diesel. But they are larger in structure, which leads to the biodiesel being especially susceptible to freezing in cold temperatures. What are the differences and similarities of large-scale production and at-home production of biofuel? Both processes more or less follow these basic steps. Algae oil is first extracted, then is reacted with methanol in a process known as esterification. This product is then followed by transesterification, a process involving adding alcohol that can be catalyzed by an acid or base catalyst. The final result is biofuel and the byproduct glycerol used in soap manufacturing. In large-scale production of algal biofuel, the production of natural co-products can be done in a way that is economical. Some companies produce spirulina tablets for nutritional use, or agriculture enzymes. Making homemade biofuel. I gathered algae from a few different places and gave them a few days to grow. Then, I united the algae, mixed a half a cup of water with them, and blended it in a blender for 2 minutes. I added methanol, then alcohol, and then lighted the mixture. After a few days, the glycerol and biofuel have appeared to have separated. I compared the time it took for a single wick to burn and compared it to how long it took for the product of the experiment to burn. The experiment was successful in producing a flame longer than the wick alone could burn, but the type of unstable and large fire was likely due to the alcohol. The important thing is that I tried. Who is making algae biodiesel? Companies such as Sapphire Energy and Diversified Energy Corporation are working on making products based on algae as a source of fuel as well as everyday goods. Many companies are in South California, because near the equator is where more direct sunlight hits the Earth. What are the challenges for algal fuel commercialization? In order to switch to biofuel as the main source of fuel would require all engines to convert to diesel engines, which is not to be overlooked as a substantial feat, land to be reserved for manufacturers, manufacturing costs made affordable, and the technology involved in the manufacturing process to be improved. How algal growth and harvesting can become more efficient. Substantial improvements would need to be made to the technologies regarding the growth, oil extraction, and production of algae into biofuel in order to resolve the issues associated with it. Some options include increasing nutrient circulation and light exposure to promote growth, genetically engineering species of algae so they do not freeze, or develop species that are able to grow in low-cost open systems.